This is Dr. Clark, and in this video we're going to learn how to do some example problems of triple integrals. So let's get started. So here we go. In this problem it just says evaluate the iterated integral. It gives us a triple integral here, and then we just have to compute the integral. So let's work this out. So it says integral from 1 to 2 for the z's, from 0 to 4z for the x's, and 0 to natural log of x for the y's, and then the integral is x e to the negative y dy dx dz. Okay, so because it's an iterated integral, essentially we just do each part separately. So we're going to integrate the y's here. So we just so equals, and we just pass down the outer integrals, and then we have to integrate the y's. Well, that's e to the negative y. So that would be e to the negative y would be the antiderivative, except we'll divide by -1. So that's the antiderivative with respect to y, evaluated from 0 to natural log of x. And then we have dx dz. I guess I have a little typo there. Dz. All right. And then we evaluate that. So we're going to get x e to the negative natural log of x over -1 minus x e to the negative 0 over -1 dx dz. All right, and that's going to be, okay, e to the natural log of x is just x, because e and the natural log are inverse functions, but it's e to the negative that, so really this would be in the denominator, so that's going to be x in the denominator. So we have x over -x, and then this will be plus because minus a minus, and e to the 0 is 1, so we have there dx dz. Okay, so now we can integrate the x's. So this is really -1. So -1, when we integrate that with -1, we'll just get -1x. Integrate x, you'll get x squared over 2. Evaluate that from 0 to 4z. And then we're going to get -4z plus 16z squared over 2 minus -0 plus 0 over 2 dz. So those are both 0. And then we get the last problem here. So here's -4z, so that antiderivative will be -2z squared. Here's 8z squared, so that antiderivative will be 8/3 z cubed, evaluated from 1 to 2. So -2 times 4 plus 8/3 times 8 minus parentheses -2 times 1 plus 8/3. And that should equal, I'm guessing, 38/3, which is supposed to be the right answer here. Let's just try that. We have a -8, and then we have 64/3, and then here's -2 plus 8/3, that'll be 2/3, so minus 2/3. So we have 62/3 minus an 8, which would be 24/3, which gives you 38/3. Yes. Okay, so that's how you do sort of just a triple integral. If they just give you the already iterated integral, you just go do the integral 1, 2, 3, boom, boom, boom. All right, now for this problem, it says use a triple integral to find the volume of the given solid. The solid is enclosed by the cylinder y equals x squared, the plane z equals 0, and the plane y plus z equals 1. So let's start by trying to think about what this is going to look like. So here's x, here's y, here's z. Y equals x squared. That's a parabola, right? That's the parabola y equals x squared. The plane z equals 0 would be the xy plane. So this is a cylinder, right? This is kind of this parabolic cylinder. Then it's cut off on the bottom down here. And then we have the plane z equals 1 minus y. So that plane must be like this, and then cutting off the top. So there's going to be sort of this blue roof on top of this black solid that's kind of down underneath of it. Okay? And of course, when that blue plane hits the ground, that's when z is equal to 0, which is really just y equals 1. All right, so now that we've kind of got the rough sketch, let's try a little bit better sketch here. Here's y equals 1. There's a parabola. So that gets cut off there. That makes sort of a region down here in the xy plane. There's a parabolic sort of surface, right? Parabolic cylinder going. And then we have this blue roof coming in on top of it. Okay, and that kind of extends all along. So now what we want to do to find the, I believe it was volume, find the volume, we need to turn that region into coordinates. So if y is equal to 1 and y is equal to x squared, that would mean the x is equal to 1 or negative 1. So I'm thinking the x's start at negative 1 and go to 1. Given an x, the y's go from here to here. So the y's start at x squared and they go to 1. Right? Given an x, the y's start on the parabola and they go until they hit the line y equals 1. And now, given a point xy, you go up until you hit the roof. So the z's start at 0 and they go to the roof, which I believe was 1 minus y. Yes, 1 minus y was that blue roof. And it's volume, so we just integrate the 1 function, dz, dy, dx. Okay, so there's the integral we need to compute. And it's just a matter of working it out now. So we integrate 1, we get z. Evaluate z from 0 to 1 minus y. That gives us 1 minus y minus 0, of course, dy dx. Then we integrate the y's. And we'll get y minus y squared over 2, evaluated from this. I must have mistyped something down here. This is supposed to be from x squared to 1. From x squared to 1, dx. So that's going to make 1 minus 1 over 2 minus x squared squared over 2 dx. And now we can integrate the x's. We'll get 1 half. 1 minus a half is a half. Integrate that, you get 1 half x. Minus, we got an x squared, so that's x cubed over 3. We've got a plus now. Minus minus makes plus. X to the 5 over 10, evaluated from negative 1 to 1. And that's going to give us 1 half minus 1/3 plus 1/10 minus, parentheses, negative 1 half, positive 1/3, negative 1/10. And that gives us, let's see, plus, that's plus a half. Half and a half makes a 1. A third minus a third makes 2/3. A 10th plus a 10th makes a 5th. And that must give us, let's put it into 15ths. 15 15ths minus 10 15ths plus 3 15ths equals, what, 8 15ths? Booyah, we got it right there. All right. So there's sort of writing down the integral, and then, well, first really turning the shape into a volume, turning the volume into an integral, turning the integral into a number. All right, so hopefully those examples help you out, and you can work out your own problems from there on out.